Good morning, everybody. Thank you for joining our session and for being here at CX Energy. My name is Jim McGee. I'm the Executive Director of Max Consulting in Gilbertsville, Kentucky. We have today a panel presentation on the importance of AI in the utility and facility management industries. I'll introduce the panelists in a minute. This is available for AIA credits, public domain images from Unsplash. The importance of AI, I think, with the increased use of energy that we see, and also the amount of data centers coming online. We all know that the projection for energy on the grid is quadrupling or tripling or even more than that in the immediate future. Because of that, there's a lot of rise for applying tools of AI, not just in the electrical sector, but throughout business. And that's what our presentation is about. We don't talk a lot about distributed energy assets, but that's a phenomenon that's occurring as a result of AI being able to integrate those into the grid, which is an important element in our infrastructure. We'll talk about AI employed, the utility industry, the various ways AI can assist facility managers, available offerings of AI systems, and recommendations. And I'm going to introduce my panelists now. We have from Exto, Buri Balasubramanian. Sorry, Suri. Everybody call him Suri. Kevin Scarborough with Siemens, and Sarah Aronofsky with Energy Cap. So thank you all for being here. I'd like you all to take a minute and introduce yourselves and what brings you to this panel. I guess we'll start with Suri.
Hi, you guys can hear me? I'll try to stand up because I think people in the back cannot see the panelists if they're seated. Co-founder of Exto. I'm an industrial engineer by profession. I've been excited about technology and AI, especially in the commissioning space, so I'm glad to be here. I'll let Kevin and Sarah kind of introduce themselves.
Sure. I hope everybody can hear me. Good morning, everyone. My name's Kevin Scarborough. I'm the Director of Energy Services at Siemens. Smart Infrastructure Buildings, that's our name. So I'm really excited to be here. I lead a team of business developers across the U.S. We're really trying to drive value around energy services and commissioning to our customers. I'm really excited to talk about AI. There's a lot of stuff that we're doing in the AI space, and so really excited to share some of some of my thoughts with you, and hopefully you'll gather a lot from it.
And I'm Sarah Uranowski. I'm the Director of Product Marketing for Energy Cap. I'm a mechanical engineer by trade, and I head up all things product marketing for us now. Energy Cap is all about centralizing, gathering, and getting value out of your utility data. So we're a software company. We've dove headfirst into AI in some ways. We're a little more cautious in others. So it's something that's very central to what we do every day, but also something we're endlessly curious about. So it's a really cool topic, and I'm excited to talk about it with you.
As far as our panel topics are concerned, we have really the core topics, which are the four: artificial intelligence for the built environment, use cases in energy and utility management, commissioning, asset monitoring, and predictive maintenance, and democratization of data and best practices. If we have time, and it's, we feel like we can get more information out of a panel discussion than trying to just go through slides. So we'll hit these topics, and we'll hit the bonus topics, time allowing. But if not, I invite you to have conversations with these incredibly talented individuals. So our first topic is artificial intelligence for the built environment. What are the different kinds of AI in play today? How do your organizations utilize these types of AI? Sarah, you want to talk about, I think, machine learning.
Yeah, so I'll start with that, and I'm the millennial on this panel, so they have beautifully written notes. Nice.
I'm not that old.
I think it's fair enough. And mine are on my phone.
Thanks, Sarah.
But they have much more beautifully written notes than my left-handed engineering handwriting would allow, so mine are on my phone. But at any rate, so machine learning is definitely one of the core types of AI, and you can think about it as a branch of AI that enables computer systems to learn from prior intelligence and prior things that it has done and identify patterns, recognize anomalies without having to be explicitly programmed to do so. So it's learning all the time. And that's core and central to what EnergyCap does in a lot of different ways, and I won't belabor it because we'll talk a lot more about it, but in how we gather utility bill data and make sure that it's accurate on the front end, and also with smart meter and sub-meter data that's coming in more real time and filling in gaps and gleaning actionable and money-saving items from that as well. We use AI in a lot of different ways for that. But machine learning is definitely one of the core ways, and I'll let you two talk to some of the others.
Sure. I will talk about generative AI, which I think probably many of you are familiar with if you've played with the free chat GPT and things like that. I think we kind of have heard in the media some of the limitations of that, like you look at images of people's hands and they look like they have tentacles for fingers, right? That's the generative AI learning it. So what is generative AI, the way that I would kind of think about it and rationalize it? At its core, what it is it generates information, right? That's in the definition of the name, where machine learning is really around categorizing data, doing calculations for you, making decisions. Generative AI is actually replying to a prompt and creating something for you, something that didn't exist in the past, based on a huge amount of data that goes into the system. So, the data is really the source of all of the prompts that you get. And it's funny, I was talking to a colleague out there, and they told me, I challenge you to find in generative AI a picture of a full wine glass all the way to the top, right? And I actually tested this right before, and it was interesting because apparently there are no pictures out there of people with full wine glasses all the way to the top. And I tested it, and lo and behold, it was up. I mean, the guy definitely was having a good time, but it was not actually to the top. And why is that, right? Because the data that's being fed into generative AI, it's all the stuff that actually already exists out there in the public domain. It's being fed in. There are no pictures of that. So, that type of thing, what I'm really stressing here with generative AI, though, is it's the quality of the data that goes in and the human oversight that's part of that. And you're going to hear me talk about that quite a bit. So what's Siemens doing with generative AI? Really two areas right now that we're really focused. One of them is we actually have an internal GPT called Siemens GPT. And it actually helped me prepare for this. It's fun. I'm using AI to prepare about a talk about AI, right? But Siemens GPT is an internal tool where we put in a lot of our websites and also external information to allow us to be more productive. Where it relates to the commissioning industry is we have a generative AI tool that we're using internally right now to be able to identify issues that might exist for an air handler, like an outside air damper, for example. So Siemens is an automation company, fire security company. You guys are aware of our business. And so we have technicians that may be new to the role. They go in, they're working on a system, and the customer asks, how many times have we had to replace this outside air damper? And so we can log into the Siemens GPT quickly, type it in, we've had to do this, and it's cost this much to the customer over a certain amount of time, right? We can help come up with some industry standard safe calculations for energy savings if we replace a chilled water valve that's leaking. Those are the types of ways that we're using generative AI at this time. So I'll hand it over to Suri to talk about, what were you talking about? Natural language.
In general, I'd like to talk about AI in three parts. If you think about it, it's a paradigm shift in computing. The reason why it's a paradigm shift is AI when I say AI, it includes ML, includes generative AI, includes natural language. It's a paradigm shift in computing because now you have machines that can understand, learn, and adapt. So that's number one. If it can learn and adapt based on data that it's being fed, that's part of machine learning, a little bit of generative AI, and that's incredibly, incredibly powerful. ChatGPT in the last 4 years have shown that the new models that are coming out are much, much more powerful than what they were because they are learning much faster, much better, processing more data. The second part of it is, of course, with that learning, it can produce content almost equivalent to a human in a lot of cases. I'm sure you guys have all used ChatGPT or other large language models, but it is actually pretty cool. Now, in terms of natural language models, what it can also do is take a look at your structured data. For example, we at Exto, we have AI built into Exto, so you can go ask questions on, show me all equipment that's going to be blue tagged in the next 2 weeks. And based on data that's available, it's going to show you all the equipment that's, instead of you having a report writer or having to process this in Excel, you can use AI and go ask a question. Show me all equipment that's, is going to be green tagged and has been green tagged without any issues, and so on and so forth. So commissioning is an extremely data rich, but environment that people have turned their back. But I think now is the time to kind of look at it, because now you have the computing power to process the data and make use of it. The last but not the least in AI is with AI you can change how you think of optimization. Meaning it used to be that a human needs to be in the loop to optimize something. Now you can introduce AI as a technology footprint to make that whole optimization or innovation cycle a lot better. And I think that's incredibly cool, because I think, as Kevin was saying, or Sarah was saying, a lot of the things we used to do was scripted. If this, then that, if this, then that. Create a program to do this, or follow a set of instructions to do that. But now you have technology at your fingertips, within reason, to kind of say, okay, think about how you would do this, and it can actually perform it for you. So it's actually incredibly cool. So with that, I'll kind of turn.
Yeah, Suri, I'll move it over to the next slide. We're going to do use cases in energy and facility management. And Sarah and Kevin, if you guys want to talk about that.
Yep. Happy to. Yep, I can start.
Okay, sounds good.
Yeah, so this is really where Energy Cap spends a lot of our time and a lot of our investment. So when you're talking about things like energy bill processing, so kind of at the high level from that information you're getting month over month in your utility bills, we've got AI that helps you accurately capture and automatically ingest that data, but also to flag anomalies and say, okay, something about the use or the cost here is unusual, let's flag that. Or your utility company has done something that they shouldn't have done, they've double charged you for a day, something like that, and can help you really quickly and easily off the bat to mitigate those costs and not have to pay them. And then also when you're diving deeper into your sub-meter data. So again, that energy data that's coming in on a much more regular basis, we have machine learning called Sentinel, and kind of similar to what Kevin was talking about as well, it's to help you say a little more practically, what should I be doing differently, or what's unusual and what should be flagged. So it can help fill data gaps. Something's gone down, your power's gone down, or something that in one area but not another. It can help you say, okay, this was your overall consumption. Can help identify patterns, flag things like, hey, you've got highly unusual water use here, and it could be something like a leak in a pool. So that's something you want to address before you have to pay that very large utility bill. But there's a couple of things that I want to say about it, and Kevin, you made a really good point about it's about the quality of the data that you're putting in, and it's about the human that's evaluating that data and making that intelligent decision about what do I want to do with this, how important is this, and making sure it rises to the top. I did some digging before this presentation about the average span that a human person has in a day to do good work, to do productive work, and it's right around 4 hours. For someone who's really refreshed, it's right around 6. But when you think about it, for focused work, that's not a ton of time. And I highly doubt that anyone in this room is working 4 hours a day, probably much more on the order of 8 or 10 or more. And one thing that's big about AI, I think, is if you can automate a lot of that lower level stuff. So if you can take away manual data entry, if you can take away some of that base processing, if you can float those actionable items to the top, then that 4 to 6 hours is going to be spent a lot more productively. And it doesn't mean that it's fully replacing or will ever replace what you do day to day in your job, but you want to be really cognizant of getting tools that are maximizing your value and your worth and your time, because you do have incredible value and worth and time. And the other thing I would say as well is AI is a little bit buzzy right now. There's a lot of folks that talk about it, and you've got 3 people on this stage whose companies and professional investment is truly to be the best of the best in that. But be selective in your tools, and when you're looking for what you want and you want a solid track record, you want to understand that the tool is really truly going to say or to do what it says it does, or you're going to end up spending more time in your day as you're evaluating, and it's actually going to add, it's going to take away value instead of adding it.
Absolutely, that was a great point. I'm going to talk a little bit about fault detection and diagnostics and maybe mention some of our modeling and forecasting. So fault detection and diagnostics, I think we all agree, it's sort of an older technology, right? It's been around for decades in some form or another. We've always been able to create fault, categories. If it's above a certain number or within a certain range, there's no fault that gets generated, right? With fault detection and diagnostics, we've heard these 3 terms in the industry. One is reactive maintenance, one is proactive maintenance, and the other is predictive maintenance. With reactive maintenance, that's kind of what we're doing a little bit with fault detection and diagnostics. It's data that's based on the past, right? How things have performed in the past. Now I can make a decision on how I should fix something so that it works properly in the future. Proactive would be similar, but it's actually addressing the issue before it becomes a bigger issue. I agree. I think we would all agree that's the definition. Predictive is the future, though, right? How do we get to that predictive maintenance standpoint? And that's where I believe AI will step in and have a really big say in the industry and what we're doing with that, because fault detection and diagnostics, in my mind, could actually be augmented and improved by, rather than allowing something to go out of range, what if it is you're reviewing the data for maybe a pump motor and you start to notice that the temperature of the motor starts to increase, but that's actually not bad. It's normal for this time of year. But what if it could flag that, okay, that motor is actually operating hotter outside of that range? It's not at a fault, right? The pump motor's fine, right? But you've got the temperature hasn't been flagged yet, but now the AI engine saying, hey, so-and-so, you need to go look at that motor and take a look at it because there might be an issue there. So you're using this wealth of data within the space to be able to come up with these models that are driven by machine learning to tell you where to look, right? That to me is one of the biggest things. And I would also say, the human aspect of this is so important, right? Maybe you replace that motor, but the AI engine doesn't know that. But you guys will know that because you're managing the facilities or doing the commissioning for the space. So you know that that's something that's not actually an issue. The human factor is going to be incredibly important with the AI, and that goes to data governance. Data governance is something I believe we're going to talk about a little bit, but it's really around how we define data, how we categorize data to make sure that it's not garbage in, garbage out, that it is clean data going in so that the AI engine can make those determinations. The last thing for a use case is around modeling and forecasting, specifically right here for the power grid. While that's a little bit outside of what we do with commissioning, I do want to let you know that there are AI engines currently predicting the demand in certain markets. For example, the actual demand based on weather, based on demographics, and things like that, so that we can properly charge batteries or discharge batteries, or charge thermal storage or discharge thermal storage using machine learning and AI. So there's a wealth of stuff. We're only touching on a couple of things, but I'll end there.
Mr. Balasubramanian, anything you want to add?
Thank you. I was just going to add, and just to add to Kevin's point on modeling and forecasting, I think that there's that part of the whole AI piece is incredibly powerful. I kind of second that with whatever Kevin said, because most of the companies, most of the people here have a wealth of data, structured or unstructured, in multiple repositories. Now, it's not too hard, and I'm just saying that as a technologist as well. It's not too hard to go get the data, make it structured, and run models against it. It's not that hard. When I say it's not that hard, it's conceivable, and it's going to become easier and easier to go start mining the data, making it machine breedable, and running forecasting models against it. And the key thing is back to quality of data. How good is your quality of data so that your models actually produce outputs that are useful? How many of you have used search on Apple phones or Google phones?
Everyone.
Everyone. Well, you have drones flying around electrical power grids taking photos every day, right? The machine learning problem, or the problem that we talk about in terms of fault detection, how hard is it for an AI model to go tell me which poles have a bird's nest in them? It's not that hard. I mean, that's problems being solved 5 years ago, except that we need to apply it to our context. And I think that it's not too far down the road where that problem is going to become so straightforward for people in this industry. They're like, okay, why are we not doing this? So I think it's going to happen. It's just that it's going to take some time, as like every other technology is coming, is making its way into this industry. So it takes a little bit more time, but it's all super promising. But thank you.
Okay, panel. Let's move to commissioning, asset monitoring, and predictive infrastructure maintenance. Kevin and Suri have this. Maybe, Kevin, you'd like to start.
Yeah, sure. So digital twins, right? We see that up there, digital twins and simulations. So digital twin, that's a word just like AI that's very prevalent in our industry. Everybody is aware. They have an idea of what a digital twin is. And you know, I've seen definitions that range from, it's a 3D model. It's almost like playing a video game from back in the day, right? It's a 3D model of a facility where you can see the chiller and the boiler and the pumps or the air handler and the valves and everything, and you can access specific data, BIM data related to those assets in a virtual environment. And if I make let me step forward a little bit. If I make a change to that system, then it should reflect the actual system that it's modeling, right? I believe the term digital twin, that is absolutely included in it, but for purposes of this discussion, I want to break it down to something simpler. To me, a digital twin is a model of how a system is supposed to operate. It's the perfect form of that system, and it can be everything from a 3D model that you can interact with all the way down to a 6th order polynomial on an Excel spreadsheet, right? Depends on the system that you're talking about. But the point that I'm trying to get to here is that, you know, a digital twin to me is something that can be used in the commissioning industry in a big way. For example, you know, let's say that we do have a digital twin of an HVAC system, and you've gone in to commission that system, and you want to check compared to the ideal scenario, if the changes that you made reflect the ideal scenario, right? You can use that digital twin to show the customer that, yes, it is operating the way that it's supposed to. Or let's say, you know, for those of you that are like in the energy services industry, that you want to go in and put in a new air handler or a new pump to save energy, that digital twin could then be altered so that you can see what the potential impact would be to that. And then internally in Siemens, how we're using digital twins is around chiller plant optimization. So we have a model that we create that when we go in and do chiller plant optimization, we would expect that after we've commissioned it and everything's working great, that the savings that are showing by the digital twin would be 0 because everything is perfect. But over time, as things degrade, we're able to compare current performance to the digital twin to tell us, hey, there is an issue here. We need to go look into that. You know, I would also add, just kind of stepping back a little bit, and I know, Suri, you can talk a little bit about this, but there's a lot of opportunities within this space of doing commissioning predictive infrastructure maintenance around data and uploading it into AI. And I'm kind of teeing Suri up here with this because it's so cool to me. You can upload single line drawings, you know, P&IDs into some of these AI engines that can then spit out a database that's already prepared for you. All the chillers, all the pumps, all the boilers lined up exactly based on what's being shown in those drawings. Nameplates, there's technologies out there that are coming out, or they are out. In fact, some of the people here may be involved with that, where you can use an app and take a picture of a nameplate of a pump, for example. And that AI will read the plate. It's got to interpret the language on that plate, for example, and then it will go to the internet or go to the database and spit out the pump curve. So by the time you get back to the office to go do your analysis, you've got the pump curve waiting on you in the app. So you don't have to go and look for those things in order to do all the homework. It's going to save a lot of time for us in this industry. It can help create reports. Right? I'm sure many of you have templates. You copy and paste stuff like that. You can use generative AI to create reports. Just really, the sky's the limit right now. I'm very excited about it, but I'll turn it over to one of you guys.
Thanks, Kevin.
Yep.
So adding to that, so 2 things on, so digital twin is actually pretty cool. There are a lot of technologies out there. I joked with Kevin earlier, if my daughter can build a world in Minecraft, I should be able to build a digital twin of a facility in Unity, and it's not too far-fetched, to be honest. There are tools out there where you can go build digital twins. You can go check out NVIDIA, you can check out Unity. There's a bunch of platforms where you can actually start a twin.
Right, yeah.
Omniverse. Mm-hmm. And the power of the digital twin, along with the simulation, is incredibly powerful, because you're basically translating the physical world into the digital world. And you can go make changes to the digital world and see the impacts before you start applying to the physical world. So that's very, very possible. So that's awesome. So in terms of commissioning, so just some numbers. So Exto is being used in one of our a very big semiconductor owner for the last 5 years. We have about 1.2 billion data points. 1.2 billion data points across equipment, checklists, buildings, hierarchies. So that's just, fertile ground for using AI. Anything from reporting, anything from analysis. So it's super awesome to see and have that data. And I'm not saying it's only for a big semiconductor owner, even for smaller commissioning jobs. The data aspect of every checklist, every failure is all digitized. Everything is digitized these days that you can go read, use that data for reporting, for analysis. So I think that that's something that, we'll be happy to kind of talk more after this presentation, but it's really, really powerful that if you can start thinking about data. How many of you have heard about this term prompt engineering? Prompt engineering. Okay, you basically use prompt engineering is a way in AI where you tell the engine or the language model, you ask a question or you engineer a prompt to get an answer that you want. So that's basically prompt engineering 101. And if you understand your data and you label it enough, then you go ask something and the engine returns back data. It could be a smallest Excel, it could be a very large Excel, or a bunch of Access databases, doesn't matter. But if you label it, you prompt it, and you get the results that you need. That's the engineering aspect of it. So that's where we should be going, and I'm happy to talk about it, since I think we're running out of time.
Oh, that's fine. Sarah, anything brief you want to add to that?
Yeah, I'll just quickly say from an energy management perspective, Sarah, you said something really, really key, I think, which is it's not just that your digital twin is your environment where you've reflected all the things that you've done and you're ensuring consistently that things are operating as they should, or maybe they aren't. It's a playground for you to decide what changes you want to make or to virtually make them in a much, much lower risk or virtually no risk way, as opposed to physically going out and making those changes and seeing what happens. So Energy Cap, for example, we, in various ways, create a digital twin of your energy usage. And one of the things that you can do with that is decide and estimate, if I do this energy conservation measure, if I replace all the lighting in all of my buildings, or if I want to use different insulation, what's that going to look like? How much is that going to save me? How much will that matter? Is it worth my investment and my time? And digital twinning helps you to create that project, estimate it, both from a conservation of energy and cost perspective, and tell you this is your ROI on that investment, without having to go out and say, well, I'm going to start these projects and I don't actually know the return that I'm going to get on that. So it's a key tool in your decision making, not just as you're making it, but long before. So utilize that environment, utilize, and again, the accuracy. If you've done the work of putting in good data, then you can use that to save substantial cost, to save usage, to do all kinds of useful things, and you use that digital twin to help make those intelligent decisions.
Sarah, you may want to stay with democratization of data and best practices and then turn it over to Kevin.
Yeah, perfect. So, an interesting thing about AI and tools in general is there will always be a really human element to it, and one piece of that human element is, as an organization, you have to be ready for it, you have to be willing to engage in it, and you have to make sure that organizationally you're going to get your worth out of it. So it's really important. There's lots of tools out there, and there's almost endless options. But I did some digging, and it's something like 80% of organizations in facilities and energy management are actively looking at AI tools that they can utilize right now. The estimates on how many of those organizations are internally prepared to successfully implement those tools is about 5%. So there's a disparity, there's strong interest, but you have to make sure as an organization you're invested and you're ready. So you want to partner with the right folks. You want to have the right tools in place, make sure that it's clearly understood what your needs are, and work with those folks to come in and make sure that you as an organization are empowered. You also have to get internal buy-in, right? So a lot of what you do every day is not just do your job, but use your influence and your expertise to, even if you don't directly manage those people, but to get things done and to make sure that things are working together. So you're the perfect team of people to utilize those skills to make sure that organizationally you're ready to bring in the AI tools and actually maximize what you need to get out of them. So just make sure as you're looking that both internally and with your partners that you've got the tools, but also and not just the budget, right? But the time commitment, the expertise, the willingness, the excitement, the buy-in on your side to use them and use them well.
Yeah, that's great, Sarah. And I want to add on to that and talk a little bit about what do we mean by democratization of data. That might be a new term. It was sort of a new term for me recently, but what democratization of data means is that there's consistency in standards for everyone in an organization. Everyone has access to the data, hence the word democracy, right? Everyone has access to the data. What's required of that, though, is data control. Right? There has to be controls, rules, and standards around what do you call the data that's going into it. Come talk to me and we can talk about working for a very large company. Very large companies naturally have silos. Everybody's heard of the word silo, right? We try to fight against it. We try to communicate, but there are silos in big organizations. And, as big organizations leverage AI like Siemens, we have to make sure that so-and-so over there that's developing something for our AI engine is using the same terminology and definitions as this department that's using AI, right? It's very important. Another thing that's critical here is data security. We haven't talked too much about security, but data security is very important. There may be bad actors that want to inject something into your AI engine. Maybe we're using machine learning to run, optimization of an air handler, for example. You have to make sure that everything is locked down, that you're following the right protocols with your IT departments and that you're operating correctly, because this is new technology and there are different ways in which bad actors could get in. Another thing is that everything needs to be auditable. right? I know that you guys don't really touch on that, but everything needs to be auditable so that how you're interacting with AI, that's something that can be tracked. And then the last thing is around role-based access control. Perhaps not everyone needs access to the brains, the actual calculations within the AI engine or the machine learning engine, the generative AI engine, right? Not everybody needs access to that, so you have to make sure. It is right now, listen, it's the Wild West right now with AI. In reality, we're coming up with some great use cases, but it truly is the Wild West, and organizations are not struggling, but working very hard to figure out the right way to conform AI into the business processes that we have so that we're very effective. So here's the main takeaway. Humans are absolutely required in this AI journey. Humans will not be replaced in this AI journey. Data governance means people. It means people and standards, and that we're working together to make sure that there's consistency and cleanliness in the data that's going into the models.
Sorry, anything you want to put on that?
Yeah, I was going to add two things. Thanks, Kevin and Sarah. And I want to say I'm from San Francisco. There's a lot of hype on AI. But a statistic that's important is 50% of all AI pilots fail. 50%. And that's not a joke, because I'm just echoing what Sarah said. If your organization isn't ready, you may have the best platforms and the best tools, your pilot's going to fail. So it's real. So your organization has to be prepared for it, has to have the right investment from the top all the way down, and put the boundaries right for your data to be clean, for your organization to be in a space to run this and try this out and make sure it works. Otherwise, it's not going to go too far ahead. And that 50% statistic is incredibly, tough to swallow. But
a lot of venture capital money going into it, right?
That's true. So apart from all of the hype, I wanted to share that. But I think back to one more thing on data. I think there's also tooling out there where you can synthesize data. So you may not have all real data for the last 10 years. But there are tools out there, and I can point you guys after the session if you guys want, where you can actually synthesize data based on your prior experience and use the synthesized data to train your models and therefore create your own models. So that's also possible. So that's another piece of it. But all of what Kevin said still holds good. Quality, security, roles-based access, and of course, organizational readiness for this to take off. But even though I'm saying all the negative side of it, there is optimism, because this is going to come pretty soon. Because I read from Gartner about 65% of all short-term decisions in an organization is going to be automated by 2026 or 2027, because it's coming. Short-term decisions, I'm not talking long-term strategic plans, but short-term decisions that you're going to make are probably going to be influenced by AI, one way or the other. So just saying, be prepared for it.
I really appreciate you panelists. You're very efficient, so we're going to move into the first bonus. We got about 5 minutes. And what we did there was, and Kevin kind of touched on it briefly, productivity booster or job replacer. I think that's on a lot of people's mind. I would add that a lot of people in the room from Test and Balance remember when digital controls came out, and direct digital controls was going to eliminate Test and Balance. It was going to be self-commissioning, and the result of it is it takes more people now because it's more complicated. So go ahead, Sarah.
I might be stealing a point from one of you, and if I am, I'm sorry. But when we were preparing for this panel, we as a team were chatting through this exact subject, and one of you said, or James, it might have been you that said, what tool that we have ever introduced in human history, and especially in digital human history, has resulted in less work for everyone, right? Like, do you work less because you have emails, or do you work more because now you can get work stuff at 2 o'clock in the morning and you're like, oh my God, I gotta do this. So yeah, there's still lots and lots of room and absolute necessity for humans, even as we get better and we make improvements with AI tools. So again, it comes down to trust your vendors, trust your tools, It's incredible that 50% of them fail, but what that tells you is you want to be optimistic but cautious when you bring those folks in, and you want to be really clear about the goals, which is always to enhance the work that you're doing. It's to save time on tasks that are not business critical, or if they are business critical, to help you gather and make those decisions, but basically to surface what you want to talk about or what you need in order to make those decisions moving forward. But it's really just, you want to be focusing on things that are enhancing your day-to-day and making it easier, quicker, faster to get reliable information, trusted information in your hand to make those decisions moving forward. But critical decisions absolutely still require your input and your guidance. So just make sure that you're utilizing tools that are maximizing that 4 to 6 hours a day that you have to do your best work.
Suri, I'm going to throw a curve on you and move to the next slide, the AI data quality and security. I think that's something you can speak to pretty well.
I think we touched upon this, but I think I'll talk about the first one, future workforce skills. I actually read this article from National Science Foundation, who usually they did a report in 2024 about future of work and AI. It's pretty dense, 200-page paper. I actually sent it to ChatGPT and asked it to summarize it, of course. And there are 3 parts to it. One is future of work with reference to AI. First point is substitution. I think Sarah talked about this. What parts of AI is going to substitute our work? That's number one. What are the things that are going to get replaced or substituted? Things that are low fidelity, like things like, I'm sorry, I'm looking at my notes, and this is not ChatGPT, I wrote this down, by the way. Things that's routine, things that can be done over and over again, data entry, basic reporting, some content generation, some of the stuff that's routine, that's substitutable. And those jobs will probably get substituted or replaced because that's low fidelity, right? The second one is complementarity, which is basically the equivalence would be software development. So if I go and say, now there are tools in the software space, in the development space, where I can go and say, can you generate, I can go draw an app on a piece of paper, feed it to ChatGPT, and generate a brand new app. It's not that hard. So, but that doesn't mean that the app is perfect. You still need a software engineer to go understand it, make some changes to it, write some test cases to it. So that's complementary, and that's going to happen. And I see the same thing in our space, where you may be able to go, like Kevin was saying, go take a picture of an equipment and go generate a bunch of things that it used to take hours. So, but somebody still has to go look at it. That's complementary. The third thing is transitionary. And what that means is that, I think back to what Sarah was saying, is there are things that are, as SMEs or as subject matter experts or experts in the field of a particular topic, most of the data sits in your brain, and that can probably be translated to a machine. That absolutely can be. How much of that is translatable is up to you, right? So you start labeling data, you start labeling content, you start thinking about how you're going to make that content available to somebody else who's going to probably get onboarded, as an example. So those are the 3 pieces of how work is going to get transitioned in the next few years through AI. Substitution, complementarity, and the last one is transitionary. So those are the 3 pieces. And at least within our company, I go and say, okay, can we get to using 50% of tools which are AI? It's a great goal. I don't think we are there yet, to be honest, but we'll get there. So.
Kevin, I'm going to pitch you a change up and move to the infrastructure slide and let you take about 2 or 3 minutes on that, and then we'll go for questions.
Sure, yeah. The infrastructure planning, specifically grid forecasting, I touched on this before, but AI is being used in this right now. I can tell you at Siemens, we do have a algorithm that we use to actually help our customers. It's really used mainly in Europe at this point, but it's moving into the United States as well, around kind of coordinating demand response, right? It kind of goes into microgrids as well. When do we go to the microgrid? When do we go to backup power? When do we discharge batteries? When do we discharge thermal storage? How do you know when it's time for that? Well, the old way of doing it is, it's going to be hot tomorrow, so let's do this. Let's change the programming this way. Let's go into the front end and click a button and make sure that we're discharging longer tomorrow or shorter tomorrow for chilled water storage, for example. AI is now being used to be able to forecast that based on weather patterns, potentially on demographic issues, like maybe there's movement of people. The future, of course, is going to be definitely on the weather front, right? How do you predict something like what happened in Spain and Portugal last week or this week, where the power completely went out, right? AI engines can now say, okay, if that happens, what do we do with our resources that we have in the building? How do we go to generators? How long should we go to the generator? Are those types of events going to be more common? That's the type of thing that we're really talking about here. And organizations, both obviously, especially in Europe, favor, focus on greenhouse gas reduction, but also saving money at the same time. The price of carbon in certain markets, for example, can dictate how long we discharge our battery, for example, or maybe the price of electricity has dropped for a day, and so we're going to run off the grid compared to discharging from the battery. Those types of things right now are being used by artificial intelligence, so it's really awesome. I just want to end with one comment. They talked about work skilling. I'm incredibly confident and excited about the future, totally optimistic about that. And I think that in the commissioning industry, we need to be running toward artificial intelligence. It's going to change this industry. It definitely will. It's coming. We have to embrace it, but run toward it, because there will be opportunities to improve and change your skill set to improve in areas that you feel like you need to improve as commissioning engineers and companies. Run for it. It is optimistic. The sky is the limit right now, and I truly mean that. This is the biggest opportunity, for many, many decades to really transform this industry, and I'll end with that.
That sounds good. Panelists, you have the microphones, so I'm going to open it up, if you don't mind facilitating the microphones for the questions. Would anyone have questions for the panelists?
Yep.
If you go get them the microphone.
Sure,
if you could,
I can hear it and I'll reread it.
Okay, sounds good. That'll be perfect.
Yeah.
Yep.
Yep.
First question is, when are the machines going to take over? Second question is, so I'm a commissioning agent. A lot of what we do is there's so much in the front end, documentation-wise, as far as building FPGs, getting verification checklists, things like that. And I've tried before to go into like ChatGPT and say, here's a series of operations, and here's an example of the functional performance test that I've written for a similar type of system. Do you see an application that's getting it failed? It wasn't able to get the workflow. Do you see that becoming something that's a workable item that can be implemented in the future? So like these are like the menial tasks that we're like, we can spit those out real quick, but then actually use it.
Yeah, I got you. So the first question was, when are the machines taking over? And you know what? I've got this buddy. His name is John Connor, I think, right? I've got this buddy. I'm going to ask him. He talks about that stuff all the time, so I got to figure that out. Truly, I don't think machines are ever going to take over. It's data governance, right? We got to control them. The second question was, and I think the panelists may have heard it, was how can we use generative AI to help with some of the menial tasking around report generation. If I feed in a sequence of operation and a functional performance test, can it spit out something that I could share perhaps with a customer or use as a commissioning engineer? Is that correct?
Yeah, I think first one, I'll just say this I read from, this is a quote that I read. AI won't replace humans, but organizations with AI will replace organizations without AI. That's from Harvard Business School. But anyway, to your point on AI and technology and reading, so I talked about structured data. So what ChatGPT is really good, or any LLM, really, really good about reading structured data. What you have is what I would call most dark data. You may have PDFs, you may have documents in different formats that is probably not readable, but there are tools out there which can consume it and read that data, make sense of it, and then of course, absolutely make it visible for the next job that you're going to be doing. So it's not too far. It's already there. So.
I just want to make a comment more than some feedback from it. But where I found AI to be most practical, for example, for the commissioning of a solar plant or commissioning a building environmental controls or something like that. The technicians are out there and they're out there performing literally hundreds of measurements on different thermostatic controls, lights, wind level, but they'll be accurate at particular professional and AI people have to pay $8 a month extra for it or whatever. But anyway, it would scan those 500 pages of those technician readings and it will let you know if everything was in range, is there any abnormalities checked, and so that's going to save you tons of time to do something like that. Like you do like a page document of technician's checklist or whatever, just check for anomalies.
That's a great example. Yep, it's here, right? Jonathan, you have a question.
Yes, thank you. I wanted to share an example from, and coming from an admitted AI skeptic, I started out with the tinfoil hat on saying, AI is Skynet and all that stuff. But recently had an aha moment. It relates to commissioning checklists, and here's a menial task. You have to go around and collect all the asset data, manufacturer model number, serial number, and some of the model numbers can be 40 digits long. So it's really kind of a drudgery type task, but mechanical contractor on his own took the initiative and used the ability of AI to take a photograph of a nameplate on a piece of equipment and extract the asset data from that and put it right in the checklist. And I thought that was a great example of how AI can get rid of some of the drudgery and kind of clear the way for us to work on other tasks. So that was a good example for me.
Yep.
That's a simplified version, basically, of what we do with build data also.
So if the AI models are as good as the information they're given and the algorithms they run, how do you ensure that you're ethically sourcing the data itself?
Yeah, good question.
One, in order to produce those models so that one model doesn't vastly take over market share over another. And then if one does within industry and it's taking these tasks, how do you still allow people the serendipity for growth and joy within their work so that they don't have that feeling of obsolescence or redundancy or whatever? Why are they even there? Just curious if you had any thoughts on how you can implore these new technologies but not have them replace base skills, like somebody not being able to find their way home without GPS kind of thing.
I'd like to take that one if you don't mind. So your first question was, how do you ethically source the data? That is definitely an unknown right now in the industry. Again, it's the Wild West. Who's going to rise to the top, right? How do we ethically source that data? That's where data governance comes into account. And I think it's incumbent on every organization to do their best at this point, barring government regulations and things like that will probably happen in the next 10 years around it, right? Antitrust to prevent one, rising in the market versus another. we've got to be very careful with that. And as organizations, as commissioning organizations, we have to act ethically. And I think right now, the onus is on us to make sure that we're doing the right thing.
Kevin, when you talked about the Siemens GPT, there's a difference between using like ChatGPT and being on the internet versus putting your data into a private database behind a secure firewall.
Correct.
So,
Exactly. It's very different, right? We're not competing with anyone with our GPT. We're just using it as a tool for us to work. And then your other question, the joy aspect, there will be a tendency to become lazy and uncreative if we're not careful, right? Think about it. Before, I used to have to go find data. I had to go to a library and do research, or go on Google and find something that's from a reputable source and things like that. So I had to exercise my mind. And while I'm doing that, I'm learning skills as a human to be able to critically think and then feel reward after I've done the research, right? There will be a tendency to over-rely on AI, and we have to fight against that as a culture, as a people, as an industry, so that we're not just going to the finish line. Because, you know, kids are already coming out of high school and college writing essays with GPT. It's happening. But the funny thing is they're creating AI engines to test when that's happening. So that's actually becoming more accurate. I'm taking classes right now, and they actually run a scan on that to see if you did use GPT. So we're using AI to check AI, right? And so we'll do that. But I agree with your concern completely, to lose the joy out of it, right? There has to be room for creativity in this industry, and as a human race, frankly. So I don't know what the answer is. Maybe Sarah has a recommendation.
Go ahead, Sarah.
One recommendation that I would have would be resist the temptation for AI to build something for you from scratch, and instead use
Amen.
use it to iterate on what you have done. Don't, hey, AI, create this plan for me, or you know, evaluate this data for me and then hand it over. But do some of that, talk about it, continue on with your meetings and your ideating as an organization, and then say, hey, AI, summarize this meeting and the action items from that, or take this plan that we've created and simplify it or make it better. But don't resist the temptation to let it create those things from the beginning, so that you maintain some of that spark and a lot of that connection, and then you're using it to enhance instead of replace.
Sir, you want to take a minute or so, and then we'll be done.
Last point on the joy. I'll call it the time scale of reasoning. AI is great in terms of reasoning in a shorter time frame. When I say shorter time frame, you ask a question, it reasons pretty fast, but it produces a result because you don't have, well, we're all wired to become, you know, instant gratification beings. So AI returns a reasoning output very, very quickly. Where we excel as humans is to elongate the spectrum of reasoning, which is where we excel at. You are given a paper, or you're given a bunch of things to do, you reason, you take time, you take a lot of time, and you look at alternatives, and you come back and say, this is what I think we should be doing. AI right now, without AGI, which does not exist right now, short-term reasoning, not long-term human reasoning yet. And I don't think I'm not saying that it's not going to happen, but I'm confident that our human reasoning time frame and time scales will continue to persist.
Suri Balasubramanian, Sarah Yarnowski, Kevin Scarborough, thank you very much for an enlightening panel.